Right. Question number 17. This is our paper number 2, 2017. Ismail, please, can you unmute and join me on this question? This is, I think I need to make it a little bit smaller in order for me to actually have some space to do any working out. Okay, Ismail, can you start reading first, please?
O and Q is a sector of a circle with center O and radius 11 centimeters. A is a point on ON and B is a point on OQ, such that AOB is an equilateral triangle.
Okay, lovely. Right, equilateral triangle. Okay, of side 7 centimeters. Okay, read the bottom part, please.
Calculate the area of the shaded region as a percentage of the area of the sector O and Q. Give your answer correct to one decimal place.
Okay, so let's try to pick up some of the key words here. Sector. Okay, we have radius. Blah, blah, blah. Okay, so we got here that A and the point AOB is an equilateral triangle. Okay, so here comes the task. Calculate the area of the shaded region, as a percentage of the area of the sector. So there's quite a bit going on in this question number 17, and it is a 5 marker. So can you first of all pick up the key words, please, Ismail, and tell me what the words mean? So first of all, what's a sector?
Is it like a section of the circle? So some O and Q.
So a sector of the circle is basically like a pizza slice where you cut a piece of the circle out. I think that's the best way to think about it. Okay, so they said here that the sector has a radius of
11 centimeters. So ON is 11 centimeters or OQ.
Okay, so this one here is 11 centimeters. Lovely. And same as the bottom, yeah?
Yeah.
Okay, lovely. Next.
A is a point on ON and B is a point on OQ, such that AOB is an equilateral triangle of side 7 centimeters.
Okay, lovely.
So does that mean OB is 7 centimeters or OA as well?
Yeah, so all of that is 7, 7, 7, yeah? Okay, fantastic. Next. What's it saying? Calculate the area of the shaded region, as a percentage of the whole lot. So let's have a look. How do you write that down? So the area of the region as a percentage of the area of what?
The whole thing.
The whole sector. So this is the bit that's shaded at the back, and the bit that's shaded at the back is actually over here. So it's going to be the bit that's shaded in the back over the whole sector, and then times it by 100 to give you that as a percentage. So that's the actual kind of the idea that we need to have. I'm just going to cut this out from over here and just park it at the top corner somewhere. So that's our end goal. So that's our idea. We need to work out the area of the shaded part divided by the area of the whole sector, and then times it by 100, plus changing it into a percentage. So how do we go about working out the area of the shaded part? What do we do? Give me an idea for that.
You use that formula.
Okay, don't give me any formula for the moment. Give me the idea. I want to work out the area of the shaded region.
You have to minus it from the triangle, whole thing.
Okay, so the area of that part is equal to what? Is equal to the area of
O and Q.
Oh, fantastic. So we're going to do the whole lot. So that will be N, O, Q, the area of that, and then minus
A, B, O.
Fantastic. Okay, lovely. So this is the key part of the question. If you don't have the right idea, you cannot do the question. So what I've done here, first of all, okay, I'm going to put it into this kind of little bubble here. This here is my or should we say this is Ismail's idea. So to work out the area of that shaded part, we need to work out the area of the whole sector minus the area of the triangle. That will give you the area that you really want. So let's go. So start give me some layer of maths now. We got the good idea. You give me a fantastic idea. Now let's give me some maths, give me some formulas. Let's put some layer on it in terms of maths now. Go. How do you work out the area of a sector?
Theta over 360 times pi, no, times pi r squared.
Now, because they mention here it is an equilateral triangle,
60.
So what's theta equal to?
60.
Absolutely. Yeah, so they've given you no physical written answer, but they told you it's equilateral. So that implies that each angle is 60. So that's can be given as a fact. Okay, and then minus the area of the triangle. How do we work out the area of non-right angle triangle, which has an angle of 60? What was the formula? We didn't use it last lesson.
Half based on half. Half AB sin C.
Yeah, remember that one?
Yeah.
So we need to know this measurement here of the triangle, this measurement here of the triangle, and we need to know this angle here into the formula for the half AB sin C. That's how that particular formula works. Is this side, and this, which will be this side, and the angle here. Now, the angle theta is equal to 60. Let's write that down. So we're going to use 60. Let's pop in the values. So it's equal to pi times by the radius. What's the radius of the sector? Is it 7 or 11?
11.
And if this is 60, by the way, what's 60 divided by 360? Just to make things a bit simple. 60 divided by 360 is? Okay, lovely.
106.
Okay, now it says AB. What's the value of AB?
7 times 7 and then sin C 60.
Absolutely. Absolutely, because the 60 is being used twice. 60 is being used for the sector and 60 is being used for the triangle. Fantastic. So now that's lovely. So that's going to give us the area of that shaded bit there. NAQB. Now we need to put that into the calculator. So grab your calculators, please. We're going to go for a ride. Okay, so we got all this first bit minus all the second, but I think we can do without brackets. I don't think we need brackets. Okay, let's go. Shift. Okay, pi time by 11 squared. Okay, and then we're going to multiply that by a sixth. Okay, that'll be the first part, and then we press replay, and then we're going to take away a half time by that. Okay, bracket 1. Come on, Salih, calculate. Get a calculator out, Salih. Get one. Get a calculator. Yeah, get a calculator. That's the whole point of me demonstrating. If you're sitting there, you're not even using calculator. It's just half. Now, when it says 7, we can just type in 7 squared to make it a bit more. Time by sine of 60. Have a look at my small box here. Got one. It sure works. And don't forget to close the bracket. Equals. Okay. We're not in round at the moment. We are midway through a question. So that's the shaded area. And we need to know the area of the whole sector. What's the area of the whole sector? Hang on a second.
It is 63.35545,185.
For what?
The whole thing.
Okay, so something's gone wrong here. Okay, let's have a look.
No, I think it's right. That's the the shaded region. What you got?
42 point something.
Yeah, I think that's the shaded region. So you do that over 63 points.
So what's the area? So we're going to do, let me, give me a second. Oh, what's it? Why isn't it moving? Oops. Come on, that there. What is this thing trying to do? There we go. So we need to now have that area 42.13782 blah 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 divided by the area of the whole sector. So what was the area of the whole sector? That's going to be pi r squared. That's going to be 11 squared times by pi times by 6th. Okay, what's that going to give us in terms of pi?
121 over 6 pi.
Okay, lovely. So let's put that down then. So that's going to be over 120. Was it 121?
Over 6 pi.
Over 6 pi. And then we have to times that by 100. So it'll be the answer that we have here, the calculator divided. We have to go back and we have to reuse this. You're reusing this part because this is the area of the whole lot. Okay, that's that part there. That's what we're doing now. So we're going back to our final step of the question now. So let's put that into calculator. So it's going to be, okay, so put the answer in there, replay on the bottom, put a fraction, 121.
Pi. 121 pi.
Is it 121 pi? Sorry, it's pi at the top.
Yeah.
Okay, shift pi.
Over 6.
Divided by 6. And then bring that up again, yeah?
Yeah.
And then we're going to have time that by 100 to change into a percentage. And that gives you the answer. Okay, I think I've put the pi in the wrong position there for a second. Give me a moment. Let me put it in the right place. The pi goes up there. That's correct. Okay, so that should give us the answer. I'm going to put the answer in red. So 66.510186 blah, 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 blah. So that's going to be the percentage that's required now. They said they give it to 1 decimal place. So Ismail, what is that to 1 decimal place?
5.
And that's the question finished, and that's worth 5 marks. So that particular question, that's what's required for that question. So what was the key part of that question, Ismail?
Understanding it and
having the correct what?
Formulas.
Having the correct idea. You've got to have the correct idea. The formulas come afterwards. You've got to know how to work out the shaded part. You start with the big part, the sector, minus the little triangle, the equilateral one. That will give you the shaded part. Then you put the formulas in to match each bit of your idea. And then you work through that. And then you do one extra bit at the end, which was the actual main part of the question. So this was here our prep work. So we were prepping, and this is the actual question being done here. Okay, so that was the background. So well done, Small. That's excellent. Right, let's move on. I think the next question that we had to do was number 22. So we need a reader. Right, let's have Layla, please join me in this question.
Okay. The diagram shows 3 identical circles inside a rectangle. Each circle touches the other 2 circles and the sides of the rectangle as shown in the diagram. The radius of each circle is 24 millimeters. Work out the area of the triangle. Give your answer correct to 3 significant figures.
Which one? Where's the original paper from last round? Put this in warm up a bit. It's too cold. Okay, that's good. So let's put some measurements on there. So the diagram shows 3 identical circles. So let's get, okay. Each circle touches the other 2 circles on the sides of the rectangle, blah, blah, blah. The radius of each circle is 24. Work out the area of the rectangle. I'm giving you answer to 3 significant figures. Okay, lovely. So now what should we do with the circle first?
Label each of them.
Label them, okay.
24 millimeters.
Remember the radius is relabeling. So the radius is 24. So this bit is 24. This bit is 24, 24, 24, 24, and 24.
Yeah.
Also, this bit here is also 24, isn't it?
Yeah,
Okay, and this bit up here is also
24. All of them.
yeah, 24. Okay, lovely. Now it says there that it's inside a rectangle, so it's definitely not a square. So we need to work out. Oh, hang on a second. This one here is also 24, isn't it?
Mhm.
And this one here is 24. Okay, that's lovely. So what's the length of our diagram so far then?
We have
4 lots of 24 there.
96 millimeters.
Okay, lovely. So we know we definitely know the length. The length of the rectangle is 96. So this is where the challenge is going to come in. So we need to work out the width of the rectangle in order for us to work out its area. So this is the width. That's what we got to most likely what we will be working out. So let's have a look at the width. So we know from the width, let's just do color code it. Oh, let's go for the green. Okay, so we have this height here, which is here. We have this height here, which is here. And then we are missing a bit in the middle because we don't know the height of that triangle. So what we're going to have to do, we're going to have to work out this. We're going to have to work out this bit here, which is the missing kind of piece. We're going to have to work out this bit here. So we're going to have to look at that triangle. What kind of triangle is this triangle here? Layla, this one, which I'm just highlighting the gray one. What kind of triangle, special name?
Isosceles.
It's everything's equal.
Oh, equilateral.
It's an equilateral triangle.
Mhm.
So if you show the equilateral triangle here, and we have, it's going to be, in order for us to work out this missing height here, this one, the one that's this piece that is missing, that's 24, and the bottom part's 24, the middle piece. We're going to have to look at that the isosceles, the equilateral triangle. Give me a second because that looks a little bit. Okay, let's have a look. Okay, well that looks even more dooley.
Worse.
That looks worse. That's better. Now, let's put a. So that's the height that we need to work out. That's 24, and that's going to be 48. So let's consider splitting the triangle into half. We don't, because at the moment, just having the whole triangle is not really useful. So we can split the equilateral triangle in half and look at those two. So what maths do you think we could use to work out this missing length that we need?
Trigonometry.
Okay, we could use trigonometry, but something a bit more.
Pythagoras.
That's it.
Okay, so we could use Pythagoras. So can you give me the formula for Pythagoras, please?
A squared equals b squared add c squared.
Okay, now we need to label it. So which is the crucial part here is, Layla, is where you label the A. So which one of those lengths is the A?
The one that you've highlighted, the green one.
No, that's the
one
A has to be the hypotenuse. So this has to be A. This one can be B, and this missing one, the green one, can be C. In B and C can be in any order. The most important one to label first is the A. So let's put the A in now. So we got 48 squared equals, 24 squared plus the C squared, which is actually the height that we require. Now, how do we work out the C from the current setup? What do we do?
You 48 squared take away 24 squared.
That's right. Opposite of adding 24 squared is to minus if you take it to the other side.
Yeah.
So we're going to have 48 squared minus 24 squared, and then we're going to be left with C squared. What do you do with the squared?
You root it, square root it.
And that'll give you the C. So we grab the calculator, we press the square root button, we do 48 squared, then we minus the 24 squared, and that will give you 24 root 3.
Do you leave it in third form?
We leave it in third form for the moment because we haven't finished the question. And so I would say leave it that. There's no benefit of changing into a decimal number, and you definitely must not start rounding off anything at the moment, because we're going to be using this calculation further on. If you round it now and then you use it in another calculation, you get this thing called rounding errors. And so the error gets multiplied, it gets made bigger, or we can make the question smaller depending on the circumstance of the calculation. So now, if W is equal to 24 root 3, is that right?
Yes.
And that's 24. We know the middle bit, we know that bit. So do we know the width now?
Yeah.
So the area equals the length times by the width of the rectangle, which is equal to 96 times by
24 root 3. Add, yeah. 24.
Okay, so there's our length and there's our width. So that's going to be really 96 times by 48 plus 24 root 3. Now we pop that into the calculator again. So we're going to write down here 96 multiplied by bracket 48 plus the answer that we just had. So I press the answer button, we close the bracket, hit equals, and that gives us a nice, lovely number. So the area is equal to 8,598.64506. So I'm just writing the calculator display for the moment. So we got to go back to the question for guidance on how they want us to give the answer. And the answer has to be given to 3 significant figures. Now this is the important part, 3 significant figures. So Layla, how would you do 3 significant figures? Where'd you start from?
8,000.
Start from here, first, second, and third. So you got to stop here and look at the next number. So what is the 8 telling you to do?
Round up.
Okay, lovely. Let me get rid of all this bottom stuff here. So when you say round it up, you mean add 1?
Yeah.
Okay, so we're going to have that becomes 10. That becomes 6. And now what do we do with this last space here? Because the decimal point's there. Do we just stop at 860 or do we put another 0 in?
0.
You must put another 0. You fill it with zeros up to the decimal point. So what's our final answer?
8,600.
Fantastic. Okay. So you need to just take key in the question. Find out what you know, what you don't know. How do we recognize Pythagoras? We go back then to the area. So we got to work out the Pythagoras first, and then we can work out the area. What's that, is this still recording, by the way? What's that? No. You got one question left. You got the juicy one left.
The last one.
Yeah. I need a tiger for that one. I mean, somebody. Ooh. Question number 23. I remember we doing questions on this in our revision session.
I do.
You want to do? Sure. Okay, so that was Layla. I think we should have Abu Bakr. You want to try this question? Have you done equations of circles and tangents before?
So I'm not confident in these ones. Can you pass on to someone else?
Of course I can. Yes, no problem.
Thanks, sir.
No problem. Okay, I think we should have for this particular question. We should have Abdullah. Come and join me on this question, please.
Okay.
Now, what's the first thing that we could do the moment that you see this bit here? This is the circle. What should we do? We should do what?
Write down the equation.
Draw the circle.
Oh, yeah.
Now, the circle has a radius of what? What's the radius of the circle?
2.
Oh, yeah, it's 2 because it's r squared.
2. Good.
Yeah.
There's your circle. Okay. It says here that the 3 halves is that's going to be, well, that's 3. That's 1.5. So it's saying basically at, so that's one, at 1.5, and you go up and you hit this part of the graph. Okay. Okay, so that's going to be 1.5 over here, which is this one, the coordinate. So this bit here is going to be √7/2. So it's nice to be able to visualize the actual question. So the question is talking about a tangent that joins there. So let's draw this tangent now. Oops. Okay. We'll grab the line and move it across. There's the tangent. Fantastic. So we got a point there, and that point is called L is the circle. The equation that P is a point on L. And find the equation of the tangent to L at the point P. There's P. There's P. There we go. Lovely. Okay. Now, so what do we need to do to work out the equation of the pink line? The pink line, we want to work out the equation meaning y equals mx plus c format. So what do we need to do first? Any ideas?
Find the gradient.
Fantastic. We need to work out the what of the radius?
Length.
So there's the radius. We need to work out the we need to work out its
3.
We need to work out its gradient. What's the connection between the gradient of the radius and the gradient of the tangent?
They have what's it called?
Negative reciprocal. Okay, that is the gradient of the tangent. That's why we've been doing all those exercises and those extra questions that we've done in the back. I remember those circles. We had loads of these circles. Remember, it was all about this. Okay, so this question looks a little bit more, but if you draw the circle, it kind of sets your mind. So now let's have a look. How do you work out the gradient of the radius? Let's draw it. Okay, that's not very good. I want to draw a straight line. Hello. That's better. There's the radius there. So if I want to work out the gradient of the radius, how do I do it? It is the change in
Y over change in X.
Change in X. What was the change in Y?
It's 7/2, √7/2.
Which is the height of the triangle.
Yeah.
And what is the change in X?
3/2.
Fantastic. Now, if that's the gradient of the radius, which is, you can see that makes sense, the height divided by base. The height is the y coordinate, and the base is the x coordinate, how far across it goes. So your x and your y. Now, how do we get from that one to the gradient of the negative reciprocal? So I want the gradient of the tangent now. So by looking at this one, how do I get to this one? What do I do to it? What transformation do we do?
You switch them around and then you make it negative.
Fantastic. You put the bottom one on the top. And then you make it?
Negative.
Okay, negative. Okay, so we get the bottom fraction 1.5, put the 1.5 on the top, we put the √7/2 on the bottom and make it negative. So we have done a negative reciprocal. We've reciprocated and then multiplied it by basically by -1. Okay, beautiful. So we have the tangent, we have the gradient of the tangent, which is this one here. We also have, what else do we know?
X and Y coordinates.
Absolutely. So we know the m value of the tangent. We know the x1 value and the y1 value. So how many values do we have now?
3.
How many do we have?
3.
3. So we currently have 3 values. three values are very important. We need to know the gradient of the tangent. We need to know a x value that the tangent goes through and its corresponding y value. So we know those three special values. And with those three special values, we need to put into a formula. Can you remind me what the formula is? It's a cousin or a relative of the y equals mx plus c.
Yeah.
Go on, then give me the formula.
Y minus y1 equals m times x minus x1.
Okay, that's lovely. That will do for me. Fantastic. That's nice. So you have memorized that formula, which is good. And remember, this is only a variation. Oh, okay. This is the variation of the y equals mx plus c. Now we need to literally drop those three values into the correct places. So if I am to highlight the correct places and show you what I'm talking about. So one value is going to go into here, the y1 value. The m value is going to go into here, and the x1 value goes into here. Okay, so everything else which is in blue stays as it is. Oh, it's going to become black now. Y minus y1. What's y1?
It's root 7 over 2.
And what's m?
3 over 2 over root 7 over 2.
And then x minus?
3 over 2.
Okay, so I think we need to do a little bit of simplification as well. Okay, what can we do? So we need to multiply that. So what's minus 3 over 2 divided by root 7 over 2? Let's quickly put that into the calculator. So we put that in the calculator and we put that as, we'll have a fraction, put another fraction on top. So we have minus, are you doing this in the calculator? Hurry up, doing the calculator, Sadia. Bring it to the bottom and put another fraction on the bottom and put root 7, bring that to the bottom, over 2 equals. Lovely. So that's given us minus 3 root 7 over 7. And then we have to multiply with the x. And then we put a minus, and that will be minus 3 talking about minus, that will give you plus. Okay, sorry, this minus talking about that one will give you plus 9 root 7. And then the 2 will talk about the 7, that will give you 14. Okay, and then we have here the minus root 7, that has to come over here. Okay, what's the opposite of minus root 7 over 2?
Plus root 7 over 2.
Plus root 7 over 2. Plus root 7 over 2 is equal to y. Okie dokie. So let's work that out in the calculators, please. So we have now 9 root 17. So we have 9 root 17, 9 root. Ismail, can you just double check the calculations that I've done? And then you put 14 on the bottom, make sure that they're correct. And then we're going to add to that another fraction, another root 7.
Is it 9 root 7?
Which one?
The first.
Oh, sorry. Okay, sorry.
Yeah, 9 out of 17.
Okay, now press del. Is that better?
Mm-hmm.
Okay. Okay, so is that it? Yeah?
Yeah.
Equals. Okay. So that is our final answer. It's a bit of a hairy one, isn't it, Abdullah?
Yep.
Right, that looks proper, serious. Okay, so now our answer, the way that we've done it compared to the mark scheme I set it out, they've left it with the root at the bottom. Ours has been rationalized. So we've got an equivalent answer to the mark scheme, but not identical mark scheme, but equivalent. So they both are correct.
So what's the other thing you love doing with these fractions?
What do you mean?
When you multiply by the denominator?
So you times it by 7, it should be
Yeah.
y equals minus 3.
Oh yeah, that bit. Okay. Oh yeah, we did that, isn't it? So if you want to make the question a little bit looking more exciting and stuff and show some professionalism, you multiply everything by 7.
7y.
So that'll give you 7y equals minus 3 root 7x plus 8 root 7. That gets rid of the denominator, and that gives you like a question like that. There you go. Fantastic. So that's like an equivalent version of the top answer. Lovely. Have you finished that paper now? So if you look at this question, even though they're using roots in there, they're trying to make it look a bit difficult, and they put 3/2 in there as well, trying to again make it look a bit more difficult. They put a top-heavy fraction. They've given you a fraction with the third in it. And they're trying to make it look, oh my, this is really confusing, but it's exactly the same. The exercise that we've done, a whole exercise in this type of question, where they give you a point on the circle, then we got to go back to the radius, we got to work out from that point the gradient and so on, and we're done. So Ismail, have you finished all the questions now, the ones that were missing?
Yeah, we finished them.
Okay, so we'll stop this video here, and then we will put that separately because there's no point putting two